A logarithmic timeline is a timeline laid out according to a logarithmic scale. This necessarily implies a 0 point and an infinity point, neither of which can be displayed. The most natural 0 point is the Big Bang, looking forward, but the most common is the ever-changing present, looking backward. The idea of presenting history logarithmically goes back at least to 1932, when John B. Sparks copyrighted his Histomap of Evolution. Around the same time it was also explored by the cyberneticist Heinz von Förster, who used it to propose that memories naturally fade in an exponential manner. Logarithmic timelines have also been used in future studies to justify the idea of a technological singularity. A logarithmic scale enables events throughout time to be presented accurately, but enables more events to be included closer to one end. Sparks explained this by stating, "As we travel forward in geological time, the more complex is the evolution of life forms and the more of the changes to be recorded. Further, the most recent periods of evolution hold the most interest for us. We need therefore increasingly more space for our outline the nearer we approach modern times, and the logarithmic scale fulfills just this condition without any break in the continuity." Two examples of such timelines are shown below, while a more comprehensive version can be found at detailed logarithmic timeline. Example of a forward-looking logarithmic timeline. In this table each row is defined in seconds after the Big Bang, with earliest at the top of the chart. The present time is approximately 7 quintillion 17 quadrillion 430 trillion spade suit 4.3 times 1017 seconds after the Big Bang. The Sun and Earth formed about 7 quintillion 17 quadrillion 200 trillion spade suit 2 times 1017 seconds after the Big Bang. 1020 seconds is 3 trillion years in the future. Example of a backward-looking logarithmic timeline. In this table each row is defined in years ago, that is, years before the present date, with the most recent at the top of the chart. Each event is an occurrence of an observed or inferred process.